But as the mines deepened, the cost of coal again became a problem. Still more power had to be achieved from even less coal if the mines were to pay their way. The answer to this problem was to use high-pressure steam. The Cornishman Richard Trevithick is given the credit for developing its use. In about 1812, he brought out the cylindrical Cornish boiler. Made of riveted wrought iron plates, it was strong enough to resist steam at high pressures.
I think, with the advantage of this fireplace, we will make a great saving. The new engine will work with steam at about 25 pounds to the inch. It is not intended to alter any part of Mr. Watt's engine and condenser, only to cut off the steam at about a third stroke and let expansion do the rest of the work.
This use of high-pressure steam to give extra work was known to Watt, but it rested with the Cornish engineers to make it safe to use. By 1835, steam pressures had increased tenfold. The Cornish engine was 4 times as efficient as the best Watt engine. 16 times better than the first atmospheric engine built by Newcomen. By 1850, the engine had become almost standardized. This model shows how the engine was arranged in the house. The cylinder and valves on the middle and lower floors, with the valve gear, in the basement and outside, the exhaust pipe, condenser and air pump. And above everything on the top floor, the beam. In order to see how the parts of the Cornish pumping engine work together, let us look more closely at this representative engine in Cornwall. Because the end of the beam attached to the piston rod moves in the arc of a circle, this parallel motion, invented by James Watt, keeps the piston rod vertical during its travel. At the top of the cylinder, 3 valves are grouped together. The nearest valve is the steam governor, which regulates the supply of steam to the center valve, the steam inlet. Furthest away is the equilibrium valve, or Uncle Abram, as the Cornish engineers nicknamed it. These are 2 of the valves which concern us: steam inlet on the right and equilibrium, at the bottom of the cylinder is the exhaust valve. The steam below the piston passes into the condenser when this valve opens. Steam is then admitted above the piston for part of the stroke. Finally, the equilibrium valve opens for the upstroke. That is the Cornish cycle. Vacuum, high pressure steam and cut-off, equilibrium. The valves are closed by the rod behind them. This is called the plug rod and is worked from the main beam. As it moves up and down, it pushes handles connected to the valves. It will be easier to see how this gear operates if we stop the engine and then put it to work. While the steam is being cut off, the piston is pulled to the top of its stroke by the weight of the pump rod outdoors. This is the position of rest for the engine. To pull down the beam again, the exhaust valve must first be opened. The steam valve is then held open by hand and the regulator opened, thus admitting steam above the piston. As the plug rod descends, it closes the exhaust valve by pushing down the bottom handle. Near the top, the plug rod closes the equilibrium valve and the piston again pauses. The cycle is then repeated. When the condenser vacuum has been fully built up, the strokes are faster and the pauses are reduced. Finally, the engine can be left to run itself. The steam to the cylinder is automatically cut off at 1/3 stroke by these levers, which control the steam inlet valve. They close the valve when the slide on the plug rod pushes them down. The mechanism which opens the valves was designed by James Watt, the use of specially timed catches on the valve controls. The exhaust valve opens when this catch is released. And when the plug rod closes the valve, it also cocks it. Below the floor is the mechanism which times the release of the catches and the opening of the valve. This is called the cataract. It consists of a small cylinder full of water and a weighted piston. As this sinks, it slowly forces the water out of the cylinder. The piston is connected to the catches, which are slowly raised. The plug rod resets the cataract and the cycle is repeated. Thus, by the use of this mechanism, it is possible to time accurately the number of strokes per minute and the length of the pauses between the strokes. The Cornish steam cycle was later applied to the rotative engine. This small engine is used for pumping. The rod linkage conveys the power to the pump rod in the shaft. The valves must be timed entirely by the engine itself, as it cannot pause at the top or bottom of its stroke. The piston is pulled to the top of its stroke by the weight of the cast iron connecting rod at the outdoor end of the beam. This rod weighs 3 tons. The gearing transmits the power to the drive shaft. The condenser and air pump are essentially the same as Watt's original invention.